Good evening, it's Engineer Heather there. I warmly welcome all of you guys on my channel Complex World. So today's lecture is about the hyperbolic function. That what are the hyperbolic functions? So you can see there are trigonometric functions with the new thing h in them. So this h is known as the hyperbolic function. So what is the hyperbolic function? In which the trigonometric identities or trigonometric functions are expressed in hyperbola instead of the circle. This function is known as the hyperbolic function. So sin hx, cos hx, tan hx and their secant hx and cosecant hx equals to these values. So you can just remember these values when you are going to solve the hyperbolic questions in calculus. So you have to put these values in them. Now you are given with an example in which sin 2hx equals to 2 sin hx cos hx, and you have to prove this by using the hyperbolic identities. You have to put these values in that question to prove your left hand side is equals to right hand side. So I am taking right hand side which is 2 sin hx cos hx. Okay, now you have to put the values of sin hx and cos hx in that equation to prove your question. 2 sin hx equals to this one, e की power x minus x divided by 2, and cos hx equals to ex plus e minus x divided by 2. Okay, so this equation will come to into ex minus e raised to power minus x multiplied by ex plus e raised to power minus x divided by 4. This one. Okay, now look at the brackets. This one is the first and second bracket. You can see that it is making the formula for a square minus b square equals to a minus b, a plus b. So this is making this kind of formula in that equation. So I can simply write ex minus e raised to power minus x into ex plus e raised to power minus x equals to this side. So use that identity square formula. In this case you will get e 2x minus e raised to power minus 2x divided by 2. So this is equal to sin 2hx. Sin hx equals to this, and sin 2hx equals to this one, equals to sin 2hx. So this is proof for hyperbolic question. So these are the hyperbolic functions, and you have to memorize these identities one by one, and whenever you are given with the question of the hyperbolic function in which you can see the trigonometric function with h symbol in them, these are the hyperbolic functions. So whenever you're given with the hyperbolic function, you just have to put their values in the question to prove your answer. So this is known as the hyperbolic function. So it's widely used in the calculus. So it's just an introductory lecture on, because the starting of the calculus. So this is lecture number 5. We are just studying the functions and graph right now. So in my coming lectures and videos, we can just study the hyperbolic functions in detail. Okay, the next topic is the parametric function. What is the parametric function? Let's say if y equals to f of x, y equals to function. In this parametric function, x and y are expressed in another variable like t or theta. Whenever you have function in your function x and y, they are expressed in term of t or some other kind of variable. These are known as the parametric function. You can see in the different examples of parametric function that we have two x and y, two equation in each case, and each of them x and y are expressed in the term t. So these type of functions are known as the parametric function. The first one is the parametric parabola, and the second one is the equation for parametric equation of circle, and this one is the parametric equation of ellipse, and this one is the parametric equation of hyperbola. Okay, let me take the first one. If x equals to a cos t and y equals to a sin t. Okay, the equation of circle is the squaring on both sides. Add these two equations and take square on both sides. X square equals to a square cos square t, and the second one will become y square equals to a square sin square t. Now add these two equations. X square plus y square equals to a square sine square t plus a square cos square t. X square plus y square equals to a square common sine square t plus cos square t. So we know that this term equals to 1, so x square plus y square equals to a. So the equation is proved for this case. Okay, these are the examples for parametric functions. Same is the case with this, taking the square on both sides. Okay, let's take the third example. X equals to a cos theta, y equals to b sin theta. Now taking the square of for both, x square equals to a square cos square theta, y square equals to a square sin square theta. From the first one we can get x square divided by a square equals to cos square theta, and from the second one we will get y square over a square equals to sin square theta. Okay, now add these two. You will get 1 on that side, and x square over a square plus y square over b square equals to 1, and this one will be proof for that case, and same is the case with this one. So you can just use, we are just using the trigonometric identities which are the constant. So if just put the trigonometric identities which equals to 1 and which equals to this and that, these are the trigonometric identities. So these are the proof for parametric function. Okay, let's solve an example by using the parametric equations. What are parametric functions? So you are given with the two equation x and y, and you have to prove this one. Okay, we have two equation, x equals to 80 square and y equals to 280, first equation, and second equation. Okay, from the second equation you can just calculate the value of a t and put in the first equation. Y equals to 280, in this equation t equals to y divided by 2a. Okay, now put in 1, put in equation 1, you will get x equals to a t square, x equals to a, y divided by, put the value of t, y square over 4a square. You will get 4a square x equals to a y square. This a 1a will cancel out with 1, you will get y square equals to